Today we're going to be looking at maximum likelihood estimation, or MLE. First, what is it? MLE is a technique that finds the best way to describe a dataset. It isn't really obvious what that means in this context, so we'll go through an example. Let's say we start with a dataset, it's just a bunch of points, and we choose a model to describe this dataset. We could choose a normal distribution, but we could also choose a Poisson distribution or a Bernoulli distribution. It's really just an informed decision, but the point is we have different options, like this green, purple, and blue one. You'll notice that some of these options aren't very good, like the green and the purple one. They kind of don't really fit the data. And that's the point of MLE. We want to find the best option, the best fit. Mathematically, this is what this kind of looks like. We have this X, which is the data points, and we say that they are described by our choice of model. So that was the normal distribution. Then these different options are really just different values of these parameters. We want to find the best options, the best parameters that describe the data. How do we do this? Well, the idea is for some set of parameters that we assume, what are the odds of actually getting the data that we did? We're going to walk through this because this might be a bit confusing. Let's say that I give you a coin and tell you it is fair. That means a 50% chance of getting heads and a 50% chance to get tails. To be explicit, this looks like a Bernoulli distribution, with the parameter being 0.5. You flip the coin and you flip the coin and you get head and you get tail. That's not that bad, we might expect that. But then if you flip the coin 4 more times, you end up getting all tails. At this point, you probably think something suspicious is going on. If the coin really was fair, then the chance of getting a heads followed by 5 tails is only 1.6%. So, since if we did have a fair coin, the likelihood of getting our data is low, then we can kind of say that this assumption of a fair coin is probably not a good way to describe the data. Okay, now how do we really implement this idea? Well, we start with our data X and a distribution whose parameters we assume and we just keep arbitrary. And this distribution has a probability density function f of x. We're also going to assume for convenience that each data point is observed independently. Now that likelihood function we were talking about before, we'll call it L, and see that it only depends on x, the data points, and p, our assumption of the parameters, or our option. This is equal to the product of the individual probability of the events. So this would be the chance of getting heads, given a fair coin, tails given a fair coin, and well, 4 more tails. We can represent this as a product, and well, that's actually pretty much done. What we have is this argmax sort of expression. We want to find the p, the parameter or the option that maximizes this likelihood function, which is, as we found, this product. The problem with this is it's not easy to solve. You know from first year maths that to solve this we need to derive this function, which isn't really pretty. So we're going to use a mathematical trick. We're going to instead put the argmax of the logarithm of the likelihood. It's not really clear why this might be true, but we're not going to cover that today. You can ask me after class and I'll happily explain, but for now just take it for granted. And the reason you can take this for granted, or why it's helpful, is because if we have a logarithm of a product, then we can actually use log laws and split this into a sum of logarithms. This is much easier to differentiate. And that's it. That's our final expression. So in summary, for some set of parameters, we're asking ourselves what are the odds, the likelihood, of getting the data that we did. And the application of MLE is linear regression, logistic regression, and Gaussian mixture models that we will cover in the course. These are important because MLE is a way of saying, okay, what are the best options of weights that will best describe the distribution of the data that I'm seeing? Thank you.